Our local chapter, largely we communicate through our meetup group website, which is probably how many of you have found us. I also often post events in the Chicago Science Field Trips meetup, and you can keep track of what's going on. Also, there's a link provided in the discussion area for that meetup group to our YouTube site, where we've got videos of many of our talks and lectures there. And we're a good group of people who believe that science is the way to understand and best cope with many of the processes and challenges that humans are faced with. So there's another book that I'm going to talk about today. This is Why People Believe Weird Things. Some words, nice words, smart people and woo-woo. Woo-woo is a term I think came up, originated by James Randi. We're going to talk more about James Randi a little later in the talk. But he came up with the notion, well, Michael Shermer, after studying this and talking to professional scientists who studied this, discovered that intelligent people actually are more likely to retain unrealistic ideas than people who are less intellectually gifted. And one of the reasons for that is this notion of entrenchment. With intelligence, with greater intelligence, comes a better ability to be creative about stringing little pieces together to maintain whatever view you already happen to have. So, along with the pridefulness that comes along with being intelligent, in many cases, comes entrenchment. So sometimes it's actually much harder to convince the smarter, the better educated someone is, the harder it is to change their minds, which might seem counterintuitive to us. Another thing, that being correct is deeply tied to emotions of self-worth and competency. I don't know are poisonous words to too many people, and they should not be. So I'm going to give an example of this. Some of you have already heard this example. I've been talking about it for a couple of months in different social gatherings. I'm going to choose somebody at random. Eric, you're my guinea pig for today. All right, I'm going to ask you a very simple math question. What is the square root of 16?
4.
Good answer. However, it's wrong. Sorry, just you made a mistake. So when I say that, when I say something you're wrong, now my guess is you're absolutely convinced that you're correct about that 4 is the square root of 16.
Yeah.
So you probably have a momentary emotional reaction that says, no, that's malarkey, of course I'm right. You may also have a momentary reaction that says, I'm a little bit angry, I'm a little bit piqued by somebody telling me I'm wrong. I'm invested in this knowledge. It's a piece of knowledge I've had for many years. I can't possibly be wrong, right? There's an emotional baggage that comes along with it. It's not just an intellectual question. And recognizing that every time we have a preconception about a thing, every time we've formed an opinion about a thing, we automatically become emotionally invested in that, even if it's as mild as taking pride in the fact that we're right. You have to actively work many times to overcome that bias. You have to be open to thinking about things in a new way or receiving new information. Now let me tell you why 4 is not the absolutely correct answer to the square root of 16. What's negative 4 times negative 4? A negative times a negative is a positive. So the square root of 16 is not just 4, it's also negative 4. So technically, the square root of 16 has 2 answers, and Eric only provided 1. Right? So that's another aspect of related to the critical thinking skills that we talked about last time, which is gathering data. Right? You have to, if you're going to make an argument about the validity of a thing, you best have examples and data, and if it's a physical process or phenomena, you'd best have evidence of it. Facts, however, are very strange things. There are things that we think we know, and in many cases, and for different reasons, we are in fact mistaken. This isn't working, so I'm just going to get it away from my face. Here's a fact. When, I think it's in this book, but it may have been in one of other Michael Shermer's many books. Here's an interesting fact. If you ask most people to give the reason why they believe most other people believe that there is a God, the number one reason that people believe in that, the number one reason people give for other people believing in that is because of fire insurance. You know what I mean by that? You don't want to burn in hell, so you believe in God. When you give surveys to people, and I come up to you and I say, why do you think other people believe in God? The number one question that those people give is for fire insurance. And yet, if you ask people who believe in God why they believe in God, the number one answer that you get is not fire insurance. The number one answer you get is because the world is beautiful and complex and amazing. And I just can't imagine that it happened all through physical processes. Now that's a much more nuanced and sophisticated point of view about why you might believe in God. And it happens to be more true for more people than I just don't want to burn in hell. All right? So whenever you're confronted with something you believe or something you think you know, sometimes it's worthwhile to dig into it a little more deeply to see if there are better answers or if your preconception is correct. Here's another example of an interesting fact. Mount Everest is 29,029 feet tall. All right? Does anybody disagree with that fact? All right? Stephanie, why do you disagree with that?
Well, because Mount Everest has various peaks that may differ.
Okay. Good answer. So let's talk about the very highest physical part, the rocky part, not even the snow on top. The rocky peak of Mount Everest is 29,029 feet tall. So that's it. Mike?
From where you measure, sea level can change.
From sea level. Thank you very much.
Sea level can vary.
That's true. Sea level can vary. So that might be implicated in changing your measurement. Yeah.
The plates are still moving, so it's growing. So
That's the answer I was looking for. Not that your other answers aren't excellent.
And erosion.
And erosion. All right, so it turns out that Mount Everest is growing at getting taller about the same rate that your fingernails grow. So it's adding, about an inch a decade or something like that. I don't remember the specifics, but it is getting taller all the time. It's growing faster than erosion is making it go away. So to say what is the height of Mount Everest, it really becomes important how many significant digits you're talking about. Right? So many things that we believe are clear and pure facts that have an exact answer are in fact measuring a dynamic situation, and they don't have a clear and direct and immediate answer. Most of the facts that science has informed us about are provisional. They're always open to revision. The height of Mount Everest, right? It's open to revision. The amount of charge in coulombs on an electron. Now, they make this book called the CRC Handbook of Physics and Chemistry. And in this book, they've got all kinds of values for all kinds of physical constants, like the speed of light, and the charge on an electron, and the molecular weight of water, and all kinds of things. Well, they keep coming out with a new version of that book every year. Why is that? Are the fundamental laws of nature changing every year? Well, no. We tend to get a little better over time at measuring more significant digits for some of these constants, or things that we take for granted as constants. For something like water, where you've got different isotopes of oxygen and different isotopes of hydrogen that make the water molecule, there's a mixture. Maybe there's some heavy hydrogen in some water. There's a small chance that you're going to get a hydrogen that has an extra neutron in it. And so you have to factor that into what's the average weight of the average molecule of water that you're going to get on the Earth. So all of these facts are in some sense provisional. And sometimes people look at the way science treats facts as provisional and says that science doesn't have its stuff together, right? Because everything's changing. One day some type of cholesterol is bad for you, another day butter is bad for you or good for you, or who knows, right? Science just doesn't have its crap together, right? Well, that's not the way science works. Science is humble enough to say we don't have the final answer on anything yet. But we do have some really good ideas that end up corresponding really well with reality. Now, last time when I talked about critical thinking, one of the things that I covered was some mental tools you can apply to get better at sorting the wheat from the chaff when you're presented with arguments. What constitutes a good argument? What constitutes a claim that is supported by evidence and clearer reasoning than others? Today, I'm going to talk mostly about cases where clear and critical thinking and appeal to scientific truths has failed miserably. Now, you might think in our modern world, the 21st century, that we would be largely immune to nonsense. Well, it turns out that there's all kinds of nonsense all over the place, and people are literally buying it up to the extent of billions of dollars a year. So I want to talk about some examples. This is an aerial view with a superimposed circle of an area in Geneva, near Geneva, Switzerland, where the Large Hadron Collider is. Okay, that's a big particle accelerator that is miles big, as you can tell by that circle drawn on the map. And do you remember a few years ago when they were firing this monster up? They said, there's a pretty good chance that it's going to create a particle that will eat the Earth. It'll turn into a black hole and it'll swallow the Earth. You remember hearing about that kind of thing? Well, some of you were here last year for my particle physics talk and maybe my relativity talk. And if you were here for that, or if you've otherwise learned some scientific facts about relativity and particle physics, one of the things that you will have heard is that all the time the Earth is being buffeted by cosmic rays, and many of those cosmic rays have an energy far in excess of anything that this monstrous machine will ever be able to make. If it were true that a highly energetic particle spontaneously turns into a black hole that could then swallow the Earth, it would have happened, and not because of this. So knowing a little bit about real science, about what happens in our world, what nature provides versus what some of our experiments provide, knowing some truths about that helps you assess the likelihood of claims like this will create a black hole strangelet that will swallow the Earth. It's just nonsense. It's not going to happen. There's a picture of what happens after that black hole forms, I guess. I guess that was taken from the space shuttle. Oh, I think that's in Hollywood, actually. Yeah. All right, here's another one. The Mayan calendar, 20th of May, 2012. The planets will align, and maybe they've got something other than gravity that nobody has discovered yet, but whatever the case, some alignment of mystical forces by virtue of these planets being arrayed in a particular geometric pattern will bring about the sudden end of the planet Earth. And there's some way that it's also implicated in the Pleiades star cluster. I don't quite understand it, but I'm not an expert in Mayan prophecy. In any case, we seem to have made it through 2012 in pretty much one piece. So I think we can debunk that. But there were a lot of people taking this very seriously because they had, star clusters and ancient wisdom and planetary alignments and whatnot. And there is some wisdom, some ancient wisdom that we still defer to. Plato and Aristotle and Socrates and Confucius and many other people across the span of human existence have come up with some pretty good ideas. Ideas worthy of consideration, at least. All right, here's another interesting myth. Somehow, alien civilizations aren't really interested in our political leaders or our military leaders or our best scientists and mathematicians. For some inscrutable reason, apparently alien visitors are interested in farmers in North Dakota. I don't presume to understand why.
You're not an alien.
I'm sorry?
You're not an alien.
I'm not an alien. I don't think like an alien. Right. What I can say is that notwithstanding all of the chatter about Area 51 and a certain astronaut that believes he saw an alien spacecraft and whatnot, notwithstanding some of these claims, there is no evidence that science generally knows about for the existence of highly advanced extraterrestrial civilizations, period. Now, couple that with there being no evidence that highly advanced extraterrestrial civilizations have built spacecraft and traveled to Earth, and it becomes even more dubious. Now, of all the claims that I'm going to talk about today, as far as I know, of all the claims that I'm going to talk about today, this one is probably the most science-like. Because the universe is gigantic, and the probability that there are advanced peoples or advanced conscious entities and technologically competent entities out there, the chances of that, I think, are pretty decent. But I can't give a number to it. I just think that understanding a little bit about how life conceivably arose on our planet from a chemical soup and the way evolution has progressed on our planet, it's not implausible to me that it has happened in other places as well. But I don't know that anybody will ever be able to make a spaceship that can travel the vast distances between the stars. That would take a level of technological competency that we don't know how to crack ourselves. We can't even imagine how that would be solved. But do I think it's plausible that there are advanced extraterrestrial civilizations? Yeah, I think it's plausible. Do I think they visited farmers in North Dakota? No. No, I don't. Maybe they're after something that I can't imagine, but the fact that we've never found any definitive evidence is also a bit telling. So I'm going to withhold judgment on this particular one. I don't happen to believe in it, and I don't think we have any evidence for it. Yes, Paul?
But I find it interesting that after solving the mysteries of crossing interstellar space, what they seem to be interested in is sexual experimentation on how basic biology works.
Right. Well, maybe they're machines. Maybe they're mechanical automata, and they don't know about biology. Why they couldn't kidnap frogs like we do in biology class, I don't know. So there was a story on CNN about 2 weeks ago, CNN.com, that said Green Bay Packers star Aaron Rodgers saw a UFO. While some people may doubt the existence of UFOs, unidentified flying objects, Rodgers swears he saw one. And he can detail the experience so well that you will buy the story. I didn't buy it. Even if you don't believe in the existence of UFOs. He was on the East Coast for a pre-draft interview back in 2005 while he was in the New York, New Jersey area. The quarterback and his buddies heard a siren outside. When they looked to see what was up, they were stunned. It was a large, orange, left-to-right moving object. Now, because of the overcast nature of the night and the snow, you couldn't make it out. It was, this is their words, not mine. It was behind the clouds we were seeing, but it was definitely large, moving from left to right. It was me, Aaron Rodgers, Steve, and his brother that saw it, and it goes out of sight, and we look at each other and go, "What the was that?" I don't know, maybe it was a spotlight, maybe it was a low-flying plane whose light was shining through the clouds, who knows? Now, if you know anything about UFO sightings or you've done research, you know that a lot of times two things are connected to UFO sightings. One is the presence of fighter jets, and two, there's a lot of sightings around nuclear power plants. So to tie it all together, the alarm we heard from 30 miles out was likely the nuclear power plant that had an alarm that went off, not signifying anything particularly dangerous. But, I mean, look at the words the newspaper or the news site used. You will likely believe after hearing this story. Were any of you convinced? Poppycock. All right, here's another myth that is all too common. Speaking of little green men or very large blue people, whichever the case may be, the idea of the noble savage. All right, this goes back to Rousseau. Now, don't get me started on Rousseau. I know that some people put a lot of credence in him, but he was a crank. He was ludicrous, some of his philosophy. I mean, like everybody who thinks about stuff, you're going to stumble on some good ideas every now and then. But he had some real zingers, and one of them was that he bought into this idea that people left to their own devices will be bucolic and kind and live in a sustainable way vis-a-vis the land and whatnot. Well, there's many books and many areas of many different research studies, some of which were recounted by Jared Diamond in his book Collapse, that talk about how left to their own devices, humans will be humans, and one of the things that humans do is we try to get as much of a thing as we can. Remember my own personal laws of economics. You use what you can to get what you want. Maybe it's your muscles or an axe or your attractive appearance or the money you have. You use what you have to get what you want. You always want more. And you will act in accordance with these first two laws until something stops you. Like you run out of resources or food, or you no longer have your physical beauty, or you run out of money. So one of the things that seems to be true is that cultures, even quote primitive, which I use reservedly, primitive cultures, let's say cultures that lack a high level of technological advancement, they will exploit their landscape just like any other human beings. How many species in North America are likely to have gone extinct because of the action of the native peoples here? Right? More than one. So the idea of a noble savage, that if we would just all get back to living on the land and living in peace, that there would be this kind of nirvana. Anthropological, sociological studies have shown that that's just not true. Now, I'm going to ruffle some feathers at some point, and I apologize in advance. I have a deep respect for each and every one of you, and my respect for your persons and your integrity as a human being does not necessarily mean that we will always agree about the ideas we share. I try to maintain a worldview that is informed mostly by science and what the scientific experts tell me. I am not a scientist. I don't presume to go out and do research. I don't think I have the patience for it. But what I can do is I can listen to what the experts are telling me about things like global climate change and the way evolution works. And I can accept that because I don't have any of my own research to gainsay it. Right? So if I ruffle some feathers when I go through some of the subsequent issues that are likely to be debunked and have been thoroughly debunked by science, please don't take it personally, right? Just like 4 is not the only square root of 16. You can be mistaken about something, and it's not a bad thing. It's an opportunity to learn. So here we go. Chiropractic. The claims are that it improves health, sleep, stress, happiness, well-being, immune system function, strength, life, mobility, and I'm sure the list could go on from there. It decreases diseases and illness and pain and aches and injuries. How acupuncture could decrease injuries? I mean, if I'm slicing an onion and I cut, I don't know how chiropractic could help with that. Bad posture, okay, I might give it that one. Depression, prescription drug use, and anxiety. So chiropractic, let's talk a minute about that. It was invented in 1895 by someone named D.D. Palmer, who was not a physician. He believed in vitalism and intelligent energy, that your body is suffused with a kind of willful intentionality that wants to be whole and healthy. And you know what interferes with this mystical power in your body that wants to be whole and healthy? Well, it's these strange phenomena called subluxations. And subluxations are always proximal to your spine. So if there's anything interfering with your health and well-being, it's because of subluxations in your spine. Now, nobody has ever been able to clearly define what a subluxation is well enough that we could go in and measure it or detect it with an MRI or a CAT scan or any other X-rays, anything that we could do scientifically. Chiropractors generally maintain that spinal adjustments are the key to good health. Chiropractic is the most significant non-scientific healthcare delivery system in the United States. And one of their models is they depend on return business. You don't just go to a chiropractor and get well. You go to a chiropractor and feel a little better, and then you go back and you feel a little better next time, and you go back and you're not feeling as well. So it's an ongoing relationship that impacts your pocketbook. Now, I'm willing to yield the point that chiropractic can help as a physical therapy process. I'm perfectly willing to admit that. For many people that have musculoskeletal issues, I think chiropractic can be a proxy for physical therapy. They had to deliver some kind of results that are positive. And if you're going to do massages and joint manipulation and flexibility and whatnot, I think there can be benefit to that. But my point of view on this is that if you need physical therapy, go to a physical therapist. Right? Not a chiropractor. Because a lot of times, chiropractors are catch as catch can in terms of the quality of their results. You could find a chiropractor who wants to do a colonic cleansing on you. You could find a chiropractor who wants to send you for an X-ray because he thinks that you've got some kind of bone defect. You can be all the way across the spectrum. There's no standard of training that ensures that every chiropractor has a scientific and medical approach to dealing with issues. So if you happen to find a good one, and that good one works for you, and that person happens to practice a kind of a physical therapy, then that's okay. But just be aware that it's not a formally recognized science. In fact, most practitioners, most in the medical community who have looked into it, consider it a pseudoscience. In many cases, if you need help with flexibility, mobility, and pain, you might be better served by seeing a specialist in that area. Here's somebody on one end of the spectrum in terms of chiropractic. Anybody not able to read that? I'll let you read it then.
It's not even dramatic.
Right.
Suspicious.
So, one of the things that generally has been tacked on to chiropractic is a notion of holistic medicine, right? Well, in principle, the very notion of holistic medicine has some merit, right? Why should I treat just your headache when you've also got a backache? Maybe they're related. Why should I treat the fact that you've got back problems but you're obese, right? Maybe those are related. Maybe your diet impacts your weight, which impacts your muscular and skeletal pain, right? So there is a good scientific argument to be made for treating the person as a whole, as an integrated unit, and recognizing that pushing on one part of your physiology may pull on another part of your physiology. And there is an idea of balance and harmony that can be interjected into that. But because chiropractic has become a hotbed of pseudoscientific medicine, again, I caution you that if you are seeking chiropractic care, to recognize the validity of any practice that entails physical therapy-like assistance. There is possibly some value there. But if they start talking about other things under the rubric of chiropractic, then maybe you would be well served to just deal with those other things with a practitioner who has a medical degree. So maintenance chiropractic involves exercise, nutrition, hygiene, keep it going or stop at your own cost. I don't know what that means. I guess it means you have to move, keep exercising. But exercise, nutrition, and hygiene are their own disciplines, and it may very well be that a chiropractor has learned some of the science about each of those, but because, again, of the lack of standards in training and certification, I would recommend that you see a dedicated practitioner or a general practitioner, medical doctor, for addressing some of these issues rather than a chiropractor who's often just giving you their opinions. And as if that weren't bad enough, some people say you should bring in your babies so that you can start pressing firmly on the spinal region of a developing human being. There have been cases where chiropractic has led to serious damage of a human body. There have also been cases where medical doctors have seriously damaged a human body. So I don't want to pick and choose. But again, my own predisposition is to go with the more scientific approach rather than one based on opinion and unscientific training. If you have a need for mobility and pain management, see a doctor, see a physical therapist. So some of the things that are added on in chiropractic, or maybe in their own practice, biomagnetic therapy. Maybe you can wear a magnetic bracelet. We had a talk about that last year. Dave came up with an excellent point that if you've ever taken an MRI, which is a magnetic resonance eye induction imaging, right? You've been subjected to a magnetic field vastly stronger than any permanent magnet you could place on your body. And if it's true that permanent magnets or magnetic fields change your blood flow, then the strength of the magnetic field in an MRI would have ripped the blood right out of your body. Right? There is zero scientific evidence that magnetic therapy, as applied to your body, has any effect, much less any positive effect. I don't know, maybe you can try a bigger magnet. Another piece of junk that is perpetrated as being medicinally relevant is crystal energy. Crystals are amazing things. They're amazing natural constructs that develop spontaneously given the right physical and chemical conditions. And they're often quite beautiful. Crystals almost always, by definition, exhibit a kind of symmetry. Well, symmetry tends to be aesthetically pleasing to human beings. So if you have a symmetric piece of translucent material that does interesting things to the light, then we're likely to say it's beautiful. And they're relatively rare. Finding a nice solid crystal is not something you can just walk around and say, oh look, there's a beautiful crystal, right? They're relatively rare, they're beautiful, they're symmetrical. Maybe they're mystical. Maybe they've got some kind of hidden power. No, not so much. There have been politicians who espouse wearing crystals. I think a member of Parliament in Britain was a staunch advocate of crystal therapy. There's this idea that if you wear the correct crystal and you sit in front of a computer monitor, that the crystal will absorb the negative rays, whatever those are, that emanate from the computer and protect your body. It's just, it's all nonsense. There is no electromagnetic or gravitational or any other effect that can be attributed to crystals that in any way impacts your health or the physical status of any objects that you happen to be around. There's claims that crystals can provide protection against harmful electromagnetic forces, such as those emitted from computer monitors, cell phones, microwave ovens, hair dryers, power lines, and other people. The Bioelectric Shield was invented by a chiropractor from Montana, Charles Brown, who claims he heard voices in his head and had visions in his bed, at least it was poetic, as to how to arrange crystals in the shape of a flying saucer in order to provide this protection. His bioelectric shields are sold for anywhere from $139 a piece to over $1,000. Sherry Blair, the wife of the former Prime Minister of the United Kingdom, wears one of these magical pendants. They are said to be medicinally proven and based on Nobel Prize-winning physics. If you go to a website and you see, based on Nobel Prize-winning physics, this pendant will protect you from microwaves. I mean, that's a fairly strong scientific sounding claim. And if you don't know a little bit about the way electromagnetic radiation works and the way crystals come about, then you might be tempted by that. That's why having a basic scientific knowledge, basic scientific acumen, I think, is so important. That's why I've been doing this for 2 years. Is because knowing a little bit about science can protect you from people who want to take advantage of you. All right, Peter Popoff. He's the guy, you may have seen him back in the 80s. He had TV shows and whatnot and these giant rallies. He would walk around and he'd say, is there somebody in the crowd who's got a knee problem? I feel a knee somewhere. I feel it, I feel the knee. Oh, it's you. Oh, what's your name? Oh, I know your name. And he'll tell you your name and he'll tell you your address. And he'll say, and your knee has been bothering you for 5 years, right? And then he'll put his hand on your forehead and he'll say, and I'm sorry, I apologize to any Christians in the room, but he invokes Jesus Christ and says, Jesus Christ, heal you! Right? And the person falls over in a stupor sometimes. Maybe it's his breath, I don't know. So, this fellow, James Randi, who was just up in Wisconsin last weekend, caught wind of this, and James Randi is a professional magician. He is an exquisitely talented magician, and he has been since he was a teenager. He spent about the first 10 or 20 years of his career being a magician and doing magic. And then it occurred to him that many people who practice magic, making elephants disappear, unlocking handcuffs underwater, whatever the case may be, a lot of people who practice magic were claiming to have real supernatural powers. And he knew better. And he knew that some of these people who were making these claims were milking people out of their hard-earned savings. So he started a one-man crusade, that has since grown into a whole movement where, as a magician, he looks for how people like this are actually doing their work, doing their trickery, as it were. And here's what James Randi found when he went to one of these Peter Popoff healing conventions. He took with him a radio tuner, and he heard something like this. Peter, there's a Margaret Downwood in the 3rd row who's got a knee problem. She lives on 1413 Mockingbird Lane, and she first complained of her knee problem 5 years ago. You know how she knew that? Because when the audience comes into the chamber, they filled out a card saying who they were and what they were there for. And his wife was reading these cards and using a radio transmitter for which he had a receiver in his ear to say, now Peter, you better find this Margaret lady. It was completely and utterly a scam. Right? And it's not just Peter Popoff that James Randi has gone after. Right? I think I told a story last week about some magic show where there was a physicist sitting in the front row with a magician. And whenever a particular magic trick occurred, the physicist, who has been intellectually trained to accept new evidence and apprehend the world in a way that should be able to change his comprehension of the world. If you see new evidence, you change your ideas, right? That makes sense. He saw the magician, I don't remember what it was, he saw the magician do something, I don't know, pull a rabbit out of a cufflink or something. And the physicist said, wow, I had no idea that was possible. I'm going to have to rethink my whole view of reality. And the magician friend who was sitting next to him said, no, don't even worry about it. I'll show you how it's done later. Right? So a lot of times, if you develop a scientific mindset and a skill to do critical thinking, you will be fooled by people who spend their lives figuring out how to trick your senses. Thank you very much. So if you see a claim that is astonishing, to quote Carl Sagan, extraordinary claims require extraordinary evidence. If you see an astonishing phenomena, you better try hard to get to the bottom of it, and don't just talk to a scientist, talk to a magician as well, especially if there's a chance somebody's asking for your money. All right, here's a litany of nonsense. The common theme here is detoxification. Because, toxins, right? That's where the whole colonic cleansing comes in and all this. The medical establishment, and by medical establishment, I mean people who have spent nearly 20 years getting trained in the way physical chemistry works, and the way biology works, and the way human bodies work, and the way you react to different chemicals. People who have spent many years training themselves, in some cases, about how all of this really plays out. When they look at some of these claims about toxins and cleansings, you know what they say? It's malarkey. Your body does a fantastic job of getting rid of toxins. That's what your kidneys and liver are for. All right? Your body has evolved from other life forms over the course of at least 500 million years, when the first multicellular life form arose. It has evolved throughout hundreds of millions of years with a capacity to deal with toxins that it produces as a byproduct of its metabolism, or toxins that it encounters in its environment. Now, are there toxins that we are now putting into our environment that evolution never had a chance to figure out how to deal with? Absolutely. But flushing your colon isn't going to fix those. Right? This is science. This is not my opinion. This is what I've learned about what the science says. And I suggest that if you're intrigued by any of these things, you do some research. And when you're doing the research, it's really easy to fall into an echo chamber. If you type in detox is good for you or something like that into a web browser, you're going to find all of these websites that say detox is good for you. And then you have to assess the credibility, credulity of the people who make those claims. It's pretty tough. So I don't have the time to sort through all of that. All I can do is, I'm going to reiterate what I've said many times before, all I can do is pay attention to what the experts are telling me. If they were telling me that a colonic cleansing is good for your body, then I might sign up, right? I'm not doing it because I'm biased against a particular practice or procedure. I'm doing it because the science says it doesn't work. Why should I waste my time and money on it? Why should I invest any emotion in it? Toxins, another thing about toxins is that they're related, they have an evil stepbrother, and the evil stepbrother is called chemicals. Did you know that there are chemicals in your food? It's a sad truth. Sad truth. You encounter any number of chemicals during your daily lives. Chemicals are everywhere. And some people are really wigged out by that fact. Everything is a chemical, or unless it's atomically pure, I guess. Yeah. Is O2, it's like O2 a chemical? It's still chemical. Everything's a chemical? Except for an electron beam, maybe. Yeah. As one writer on science-based medicine says, this fear of chemicals and toxins is related to 500-year-old plus notions of evil humors, miasmas, and even demons. These kinds of ideas were put to rest by the germ theory of disease. Except, not so much. They're back, like zombies rising from the dead. People are like, oh, bad air. You know? And then down at the bottom is the apple, which has a big stamp on it, GMO. So one of the products of GMO is that they take a gene from a carrot and they insert it into a very common staple food in Asia, which is rice. And this gene from a carrot causes the rice to produce something like beta-carotene. So the rice becomes much more nutritious, and it avoids, it helps avoid blindness in children, right? And the first world, America and Europe, are saying, no, GMO bad, tampering with nature, bad idea. Sorry, you can't have that. Meanwhile, children are going blind. Now, there are other GMOs that, in fact, the most common GMO process on the planet builds in a tolerance to a pesticide called glyphosate. Now, glyphosate itself may be bad for you in quantity, and it is sprayed in quantity on plants that can tolerate it because they've been genetically engineered to tolerate it. So there may be individual cases where GMO modification leads to outcomes that are deleterious. But now let me replace the word GMO with the word chemistry and see if you have the same reaction in your heart, in your emotions, in your mind. There may be chemical processes that give rise to deleterious outcomes. TNT, anyone? There may be chemical processes that give rise to advantageous outcomes. Cleaned and filtered water, anyone? Right? So just because chemistry can have outcomes that are very dangerous and outcomes that are very beneficial doesn't mean that, well, sometimes chemistry should be bad, so we shouldn't do any chemistry. Do you see how absurd that argument sounds if I use the word chemistry? If I use instead the word GMO, many of you will feel differently about it because GMO tampers with nature. Well, so does chemistry. So does electrical power. I remember this thing back in the 80s and 90s. They may still do it. I don't go to the store much. Fortunately, Dave does a lot of that for me. I'm kind of shut in. No sympathy required. I'm reading. So I remember back in the 80s and 90s, there was this thing about no preservatives. And I came up with this joke. You know, advertising a food with no preservatives is like advertising a house with no electricity. Your food will rot before it gets to your car. Okay? Preservatives aren't inherently bad, right? Some preservatives may be found to be bad, but you have to take these on a case-by-case basis. And blanket condemnations are almost never warranted, whether it's a blanket condemnation of GMO technology or chemical technology or nearly any other kind of technology. This is a classic conundrum. Think about this. How many of you have heard arguments like that? It's a catch-22. All right, more ruffled feathers. Our fate is written in the stars. Horoscopes and Now, in ancient times, and even into the modern day, you can notice that the position of the stars changes, and when Orion is overhead in the northern hemisphere, it's not a good time to plant corn. Right? So maybe the stars are telling us that we shouldn't plant corn. Maybe the whole reason for the stars is to guide the kinds of activities that we should undertake. Now, if we lived in an agrarian culture, which most of humanity for most of our history has done, then the stars and the positions of the stars in the sky from day to day and season to season can well inform us about what to do when to plant various crops, when the fish will be running, when the rivers are likely to start flooding. All of these phenomena are related to an underlying cause. See, they just got cause and effects mixed up. They thought that the cause was the position of the stars and the effects was rivers flooding and crops blossoming and whatnot. It turns out that both the position of the stars and the fact that springtime floods came, both of those were related to a third underlying phenomena that nobody knew about, which was the tilt of the Earth's axis. Right? So a lot of times, as we are progressing on our journeys to understanding the natural world, we will find false correlations. And we will presume that one thing may be causal, when in fact it is not. It is an effect of an underlying cause that we have yet to discover. But if you live in an agrarian society where floods and harvests are very important to you, and you see that the stars are giving you clear information about when these things are going to happen, then maybe you would impart upon the stars a kind of agency and relevancy that they do not warrant. Maybe they become relevant to individual human lives and the seasons of our lifespan in some way. And maybe the season in which you were born is relevant, or the stars under which you were born. And then, as if that weren't strange enough, they knew of 5 wandering stars, which literally interpreted from the Greek is planets. They knew of wandering stars that behave much differently than any of the others, and so they must be especially important. Right? Now, probably most of you, if not all of you, recognize that planets are moving under the influence of an inverse square gravitational force created by the sun, and we well understand the parameters of those orbits. Right? There is nothing mystical and magical about it, but that doesn't mean that it isn't wonderful and wondrous. And it has nothing to do with individual human lives. Astrology is bunk. So, sometimes harm comes from listening to bunk. Right? Sometimes it's appealing to us to not get an injection, but instead to eat a cabbage, or maybe some peanut butter, or who knows what. Sometimes it's easier to change what's in your refrigerator than it is to go to the doctor. And if that's your predilection, to try and understand what you can do for self-help, you can find any number of untrained professionals that have all kinds of ideas about how you can help yourself. Help yourself to their garbage. Right?
I just want to add, it's amazing the coincidence that each of those ingredients are required in the exact proportion of the others.
Yeah, 1-to-1 ratios. Somebody did a lot of research for this, I'm sure. And this is one of the most catastrophic pseudoscientific results to have plagued our modern world in recent history, the first world, and that is the anti-vaccination nonsense. Andrew Wakefield published, he's a British physician. Sometimes physicians also make strange claims, right? He has since been decertified, and this study, when people tried to reproduce his study that showed a clear link between measles, mumps, and rubella vaccine and autism, a clear link in his data, amazing, new science, oh crap kind of science. When people went back and tried to validate it, they found that they couldn't. And then when they looked at his original data set and his analysis, they found that he was lying. And yet, they're still making movies about this supposed link between vaccination and harm, specifically autism, that descends upon families. They prey on families with children. It's horrible.
It might be good to explain that one, because maybe not everyone can see it, but they're letting the doors open from extinction for polio and measles and mumps, rolling out the red carpet, and the anti-vaxxers are opening up the doors to allow these terrible scourges to come back into the world. They've been shut up and kept away, right? And now the anti-vaccination group has allowed this to come back in.
Yeah, herd immunity is being compromised. Yes.
And that small study that he supposedly did got published by a lot of media specialists that should have fact-checked him and never did, and that's how it spread so far, was because they were willing to print stories that were not founded.
Yeah. Yeah, if you come up with a novel claim, remember extraordinary claims require extraordinary evidence. The media, too often, is motivated just by the extraordinary part of that, extraordinary claims, right? Sound the trumpets, roll the presses, update the websites, send out tweets, right? This extraordinary claim has just been made. You know, we've built a culture of infotainment that wants to be the first to hop on some extraordinary claim, and due diligence often falls by the wayside.
And sometimes celebrities get involved, which makes it worse, like Jenny McCarthy,
Right.
who,
Yeah.
who lives in our town. by the way. She's a bit of an embarrassment.
Jay Cutler and his wife are the new ones.
Yeah.
I wanted to say something too about ordinary claims, going back to the horoscopes, that very often the day-by-day prognostications are so general that any gullible person can read into it whatever they want to. And so it's taking a little bit of self-knowledge and, you know,
Right.
massaging it.
There's a YouTube video of somebody saying, what's your horoscope, what's your sign? And then I'll hand you a piece of paper, what's your sign? And then I'll hand you a piece of paper, what's your sign? And they all read it and they say, now how many of you think that your specific horoscope was relevant to your person in your life? And nearly everybody raised their hands. And then he said, I want you all to exchange papers with the person beside you. And the papers all say exactly the same thing. Horoscopes, that's what they are. All right. Breaking news. In 1796, a German by the name of Samuel Hahnemann, a German physician, came up with the idea that like cures like. And that became something known as homeopathy. How many of you have heard about the idea of homeopathic remedies? All right. Now, I'm not going to ask you to raise your hands, but there's a very common misconception that a homeopathic remedy is any kind of natural remedy. Well, that's not true. A homeopathic remedy is a very specific thing, and I'm going to make one today. I haven't had a chance to do a show and tell yet, well, for quite some time this year, so I'm going to start this off with something highly.
Rolling fireflies. Wow.
Yeah.
Beaker.
I love Amazon.com. All right.
Beakers must be scientific.
Right. Okay. This
Candy crush.
is engine coolant. There's a big warning on it. Warning, harmful or fatal if swallowed or inhaled. Dangerous stuff. By the way, it tastes sweet. So a lot of animals, if you leave some of this in your garage, spilled in your garage or open in your garage, dogs and cats will tend to go to it because it smells sweet and it will kill them. This happened to my father's pet. Okay, so this is poisonous, and I want to become immune to this. Now, the idea is that like cures like. So this is a special kind of alcohol. This is green food coloring. I just want this to remain highly visible. So here's what I'm going to do. I'm going to take 0.25 milliliters. I'm going to unstopper my scientific apparatus. There's a piece of cardboard on this one. It's poisonous.
It's going to get contaminated by bacteria in the air.
You're probably right.
Have you tried this before, Scott, or should we call it?
All right, the number for 911 is 911.
Is this a call for help?
Okay, here's this iridescent, almost fluorescent green junk. Okay, it's kind of spread out in the eyedropper, but there is 0.25 milliliters in here. I'm going to very carefully, that's like 3 drops, okay? Now, according to homeopathy, what you do is you take something that you want to be cured of or made immune to, and you dilute it. And apparently there's some ritual that you have to go through, like you have to hit it against your palm a certain number of times. Maybe it's 100. I'm not going to do that. This is probably not going to be a very effective cure. It's unlikely to die. So you hit it against your palm a certain number of times, and you've got this nice and diluted. And then you go in here, and you get another 0.25 milliliters. And you do 3 drops in there. There we go. And then we put a stopper on this, and then we shake it all around, and we do this, and we put all positive, everybody, positive energy. Ready? Positive energy. Great, I can feel that. That was wonderful. Okay, and then we take 0.25 milliliters of this, and we put it in here, and we do the same thing.
You better be careful, that solution's getting pretty powerful. You better put on your safety gloves.
Oh my gosh, you're right.
Yeah.
I forgot all about that.
Would a larger beaker be more efficient?
Yeah, so here's the thing. The more dilute it gets, the more powerful it is. Anybody who's taken chemistry knows how interesting that claim is. And I take 3 drops and I put it in here. Positive energy, positive energy, positive energy. Right. And then this. And Dave and I, before we came here, we were a couple minutes late because we were doing some math. And Dave and I did the math on this, and we found out that the amount by which 0.25 milliliters is diluted by a 100 milliliter flask 6 times is, are you ready for this? Count with me here. 0.0000000000000000000001. Right? That's how much diluted this is from the original 3 drops. Okay? I'm going to drink it, and that should, according to all of the science of homeopathy, I'm going to do it one more time just for good measure because I really want to be cured. Remember, the more dilute, the better.
It's going to cure you of antifreeze?
It's going to cure me of any vulnerability to any kind of alcohol because like cures like. So I'm going to get schnockered tonight. By the way, do you see any green in here?
No.
Yeah. Here's my Humanist cup. I don't know, if I had positive energy, it would be in my Humanist cup. Here we go. All right, thank you all. It's been good. I've got more after this, by the way. Just in case this is sayonara. Deadly stuff. Deadly. That, my friends, is homeopathy. It is malarkey. Yes.
I had actually medicine was the late science. It was founded upon employing scientific methods and using numbers to understand sick people and open dead bodies up. So as a result, the standard medical applications that were done to patients were horrible. People died. So I had one thought, or maybe you do less medicine, you thin dilute this. So you have a certain set of point. Of course, it's a misunderstanding. You should know. Say goodbye to that. But
well, they also had the smallpox vaccination was new at the time, where you know, like cures like. A little bit of cowpox could inoculate a person against smallpox. So again, it's the way science tends to work, is you come up with an idea that has some plausibility and then you test it. But some people take ideas that are 200 years old and they run with them to absurd ends. All right, here's manufactured uncertainty. 13,950 peer-reviewed articles about climate change. 24 reject the idea of global warming. It's always good to have scientists who gainsay your prevailing opinion, and there have been some about global warming, but it's a tiny fraction. You can have manufactured uncertainty. Uncertainty and extraordinary claims are often political forces, not just scientific ones.
Isn't there a movie coming out about that? Sarah Palin's story?
I've heard something about that, and I don't know the details. All right, now there's this guy, my favorite whipping boy. Deepak and his quantum woo-woo. Ageless Body, Timeless Mind. This book was published in 1993. Ageless Body. How's it working for you? We all knew this would happen if we waited long enough. Nobody should take this nonsense seriously, and nearly every word he writes or speaks is nonsense. Let me give you a quick example. He was in a debate with someone that I saw on YouTube, and he said, quantum mechanics talks about how everything in the universe is connected to everything else, and how there is indeterminacy and infinite potential between any two entities. And what is God if he's not infinite potential? So therefore, quantum mechanics proves God. That logic, does that fit? Does that set with you? Yeah. Extraordinary claims, indeed. Right, another bogus claim. We use 10% of our brains. Well, I know some people, during a given day, you're likely to have used nearly all of your brain. Your brain is compartmentalized. If you turned it all on at once, you wouldn't have enough oxygen to run it. Right? So your brain has different areas for different functions. If you want to know more about some of these crazy claims, go to Skeptics Dictionary. It's a wonderful website talking about logical fallacies and debunked science. Science. What the heck is science? Versus non-science. Here's something about the pineal gland and sacred geometry. This is a real thing. There was a conference with like 1,000 or more attendees, and you can find this on YouTube, this guy talking about the link between the pineal gland and sacred geometry. People buy this literally and figuratively. So what is science versus non-science? A common idea is Popper's idea of falsifiability. That if you can't falsify it, then it's probably not science. There's nothing you can say to an astrologer that will likely convince them it isn't true. There's no evidence you can provide that makes them change their mind. That can be said for nearly any kind of poor science, or what we would typically call pseudoscience. There's problems with this idea of falsifiability. Statements that assert the existence of something cannot be falsified simply by one's failure to find them. So, I assert that black holes exist. Now, so far, science has only found indirect evidence of black holes. Nobody has actually gone up to one and poked it with a stick, right? So, just because we haven't clearly found evidence of the definitive existence of a thing doesn't mean that the theory that justifies that thing is, in fact, incorrect. Falsifiability sometimes fails. Science doesn't operate by trying to disprove things. That's another problem with Popper's idea. The Large Hadron Collider in Geneva, Switzerland was not built to not find the Higgs particle. Let's spend several $billion, turn this thing on, and hope that we don't see anything. No. So science doesn't actually work by trying to falsify things in many cases. It tries to also make predictions and validate those predictions and assertions. So falsifiability is probably not a sufficient condition. I'm going to skip this a little bit because of time. So let me talk a little bit about science, some of the views that I have acquired about science and the role it plays. This is from a movie called Howl's Moving Castle. A fun little movie, fun book. So, constructing models of things and processes in the natural world, that is science. Models that do an ever better job of approximating reality. This is a fairly interesting looking model. Doesn't look like anything real, but it's a start. It's a first attempt. Science is a meritocratic, right? You know what a meritocracy is. The best things, the most deserving ideas come to the top. Science is a meritocratic program of continuous improvement such that models are refined or replaced based upon their fidelity with regards to the evidence. For example, a common model of the ways and amounts of energy radiated from the sun works, that's a model, is that the Earth should have a surface temperature of 0 degrees centigrade. Well, clearly that's not our reality. Does that mean that our science about the way the sun works is wrong? Possibly. Maybe, though, it means that we're overlooking something. Maybe there's more to the heat of the Earth than the sunlight energy falling at any one moment. Maybe we need to consider that oceans and air absorb heat quickly and release it more slowly. We have to bolt something on to our basic model we have about the relationship between the Earth and the sun and the heat entailed in that relationship. From a human standpoint, science entails a parallel program to that of discovery and insight. It's a parallel program of unbelief, of letting go of ideas and models that have less merit. Scientific models must agree between themselves, and in doing so, they will paint an even more accurate image of reality. Notice that this model is becoming more realistic looking, plausible looking. If your climate model says that the Earth is not 0 degrees because CO2 traps heat, and you measure more CO2, you should probably expect to measure more heat retention. If the Earth's polar ice is melting, then maybe that means the Earth is getting warmer. If species are moving north, like bugs that eat pine trees, then maybe it's because the Earth is getting warmer. If permafrost is thawing, maybe it means the Earth is getting warmer. If sea levels are rising, maybe it means the Earth is warming and melting more ice. And oh, by the way, warmer water expands a little bit, and that accounts for about half of the sea level rise we've seen. All of these scientific models about the way water works and air works and heat works, these very complex models go together to inform our view of reality. Scientific theories should also be able to rule things out as well as in. They should not be so broad that everything could cause anything. They should be good enough models of reality to be recognizably reconcilable with many lines of evidence and yield an ever-improving framework for understanding reality. The picture that develops should, over time, get rid of superfluous and strange inconsistencies and incongruities. If you believe the Earth is warming because its orbit is changing, then you better have an explanation for how gravity is variable with time, or something else of similar fundamental importance. Maybe you think the Earth is warming because trees are quickly evolving to become much better heat sinks. So we should cut them down faster. Well, you'd best be armed with evidence that trees today make a better blanket than trees of yesterday before you start acting on that. Science is a process, a method, a field of study, an ecosystem of ideas. Science is the means by which we humans, with wonderful abilities to imagine and to form abstract symbolic representations, such as language and mathematics, are able to symbolize and ultimately model reality in cognitively manageable chunks. Now, think about it. If you wanted to make a perfect model of a thing, absolutely perfect, let's say it's an airplane, you want to model it perfectly. Every rivet, every wire, every panel, everything behind every panel, you wouldn't end up with a model, you'd end up with an airplane. Well, if you want to model reality, the vast cosmos, billions of light years across, if you want to model it perfectly, you'd have to reinvent the universe. So our models are necessarily shortcuts to understanding that pick out a particular phenomena, like the way the electron reacts with a photon, say. And we build models of that, and then we test it against the evidence. Over time, our models, often called scientific theories, ever more closely simulate, predict, and explain the world we see. From the whims of wind spirits to the latent heat of atmospheric carbon dioxide, humanity has made tremendous progress towards understanding reality with ever greater fidelity. Granted, as systems become more complex, our ability to fully model and systematically comprehend them becomes less accurate. From microbiology to ecology, our understanding remains significantly incomplete. Or consider the brain, the role and interplay of axons, astrocytes, and action potentials, all the way to theories of consciousness, remains mysterious. The road to enlightenment is long, and it is not a single, broad, Appian way that leads unerringly to perfection. Really, it's more like a network of thoroughfares and wagon trails. There have been many dead ends along the way, paths that once seemed to hold promise, like here's life. What a shame if we in the 21st century still wander in a twilight haze along roads that have proved to lead nowhere, putting too much stock in old ideas that do a poor job of reconciling with reality. More shameful still if too many ignore the facts we know and in their ignorance waste time, money, energy, and their very lives, perhaps all our lives, by wandering in a superstitious darkness. Whether they hold to Bronze Age nonsense or New Age non-science, we as a people, as a country, as a species, we can do better. We can let science guide us as we consider ways to make our lives genuinely better, or we can wander blindly, grasping at anything that promises to make us simply feel better. At best, this nonsense delivers nothing. At worst, it does real harm. We can do better. We know the way. Science is not some mere alternative to understanding nature and our place in it. It is a body of hard-won, meticulously gathered truths about how nature works and how we exist within and as part of it. Science is so simple a word, but it means literally everything. There are no alternative paths to understanding, because if something is proved to be true about the universe, it becomes part of science. From quantum entanglement to quasars beckoning from the edge of time, from the amazing properties of the placebo effect to proof of other worlds, an exploration and explication of nature seldom comports with our prior prejudices about how the cosmos should be arranged. We are constantly faced with awe and wonders enough to fill numberless lifetimes. And that bounty of discovery stretches far beyond what a single curious mind can grasp. If you also are filled with curiosity, then strive to understand what is real and relegate wishful thinking to ideas about mystical magics and to efforts expanded for entertainment purposes only. The idea that science is literally and by definition the best we can do to figure out why we've all gotten to here and now, and what options and opportunities lie ahead. That is the core reason that I am a humanist. For me, humanism combines a love of nature and knowledge with compassion for humanity and a desire to improve human society and well-being in ways that are both possible and practical. We must concede at least one thing, though. Science does not have all the answers to every process and thing we know is real. These gaps do not mean, though, that there are things that cannot in principle be known, only that we haven't uncovered the path to the relevant insight. The method of making models of reality and comparing them to the evidence of nature has proved spectacularly bountiful, while alternative methods such as mystical revelation, appeals to extra supernatural agencies, or the supposed actions predicated upon the caprices of transcendent beings have all proved, demonstrably and conclusively proved, to be mistaken. No rain dance, no prayers, no horoscope, no palm readings, no pyramid power, no alien intervention, no healing auras. Nothing of the sort has ever shown success beyond mere random happenstance. I recommend you stick with a proven winner when it comes to your health and well-being and other important things. Thank you very much. Next month we will talk about unanswered questions in science.